All right, good day everyone. This is Jason Straight with the CloudPass Virtual Group. Our presentation today is Introduction to Azure Data Lake with Oskari Heikkinen. He's going to be going through Azure Data Lake and talking a bit about all of the components that go along with it and what is the current mix of technologies that you should be using. Before I get into that though, or before I hand things off to him, I'm going to go through just a few announcements here to talk about the virtual group. So to start with, this virtual group is brought to us by Quest's Spotlight Cloud. Spotlight Cloud is the first Azure-hosted database performance monitoring solution focused on SQL Server customers. Leveraging the scalability, performance, and built-in security of Microsoft Azure Cosmos DB, Spotlight Cloud focuses and combines the best of the cloud with Quest's engineering insights from years of building database performance management tools. If you are interested in presenting, I am always looking for additional presenters. There's a couple ways that you can do that. The first is if you email me at cloud@pass.org, I can get your information, get everything put together, and we can get you onto the schedule. The second way is if you would like, you can reach out to us at cloud.pass.org and fill out the form there that is under the Cloud Virtual Group call for speakers. There is a third way, and that's actually the way that most of our speakers get brought into presenting, and that's by doing a presentation at a SQL Saturday. I tend to go back through the old SQL Saturdays and look for people that have presented on Azure, and we'll send them emails and ask them if they are interested. So we are always looking for more presenters, and if I haven't reached out to you, please just reach out to me and we can get you on the calendar. This virtual group is part of a large number of other virtual groups that are out there. So if you are interested in learning in maybe your native language and you speak either Chinese or Spanish, there's virtual groups for you there. Or if you want to just focus on specific areas like we focus on the cloud, other areas focus on hybrid virtualization performance. So there's lots of different opportunities to continue learning through PASS. And that concludes all of our announcements for today. So at this time, I'm going to pass things over to Oskari Heikkinen for Introduction to Azure Data Lake. Now, let me just get to there. All right, you are now the presenter.
Fantastic, thank you, Jason. Let me know when you can see my screen. I will get started right after.
Yep, it's coming through perfectly. Looks great.
Fantastic. So, hello everyone. My name is Oskari Heikkinen, and short intro about myself. What I'm doing right now. I've been building data platforms on using Microsoft technologies since 2011, and for the past 5 years, I've been working solely building a data platform and analytic solutions on Microsoft Azure. So my current responsibility at CGI is to be the subject matter expert for the solutions that we built on Azure. So please feel free to contact me if you have any questions. Also, after this session, I've made a couple of YouTube videos about Data Lake as well, so you'll find it in them if you do a YouTube search with my name and Cloud Analytics. With that being said, let's jump over to our topic. So this is how Microsoft sort of describes their Azure Data Lake. I took this picture from the main page, the landing page of Azure Data Lake. If you check out on Microsoft's website what it includes. So the first thing we notice here is that we have the separation between compute and storage. We have several services on both of these layers. On the storage layer, we have the good old Azure Blob Storage. Then we have Data Lake Storage Gen 1, introduced a couple of years ago. And now also the Gen 2 is generally available, or has been generally available for a few months now. And we also have various technologies on the compute side. due to the fact that we have several very different use cases that we may be looking at. We may have a traditional batch-based processing use case, for example, in ETL type of scenarios where we just need to transform some data. Let's say every 24 hours would be probably quite common use case or scenario in batch processing use case. Then we have a more interactive type of query needs. For instance, a business analyst or data scientist might need to slice and dice through the data the way they see fit in their specific scenario when they're trying to gain some new insights. So we have different technologies for that one as well, and then we have, of course, also the real-time use case where we need to process the data in real time as well. So from that perspective, starting from the left-hand side on the compute layer, we have something called usequal, which refers to the service called Data Lake Analytics. Then we have 3 different technologies. We have Hadoop, then we have Spark, and then we have Storm there. And if we look at how these different technologies map into services, first of all, each of these services do have a different sort of position in how easy they're to use, and also like how much control do you have over the service. So of course you can set up your own Hadoop cluster on VMs if you would like to do that. That's something that I haven't been seeing too much around, luckily, because to be honest, there is pretty much nothing you cannot do with the other services there when it comes to the different use cases, I would say. So we have HDInsight for Hadoop and Spark. Then we have Azure Databricks for the Spark technology as a service. And then we have Data Lake Analytics, which is basically query as a service type of approach where you just submit your query and the execution will start almost immediately after submitting the query. So you do not need to provision any compute as such yourself. And as mentioned, there are several services on the storage layer. So we have actually connectors for all of these different storage services from all the different options on the compute as well. If we start from the right-hand side of the previous diagram, we had Data Lake Analytics there, and the history and background behind that is that Microsoft had their internal big data processing needs. So they had their internal product called Cosmos, and what they have done here is they have productized the storage layer of Cosmos and now offering it to customers with a service called Azure Data Lake Storage Gen 1. And what that is, it's essentially a file system. More specifically, it's a distributed file system. This slide talks about Hadoop distributed file system. I would say that that's a bit of an understatement if you compare how Data Lake Storage Gen 1 has been built compared to HDFS. And then, of course, enterprise grade. So you have all the required security functionalities in place as well. When it comes to the scaling, you can store very large files there, and you can process them in parallel using the Data Lake Analytics, for instance, or with the HDInsight or Databricks. And how the distributed file systems such as the Data Lake Storage Gen 1 works is the fundamental idea that it splits the files into smaller chunks and distributes that into several disks across the data center, and that of course brings you some overhead, but also the capability of having size that are files that are the size of 1 petabyte, for instance. It also has the same 99.9 SLA as most of the Azure services, and unlike blob storage, this one has a hierarchical file system, so it's also optimized for especially for analytics purposes. Then when it comes to data security, it uses the AES 256 to encrypt always the data at rest. You can configure that one so that either the service will just manage the keys for you under the hood, or then you can also have the keys stored in Key Vault if you want to manage the keys yourself. And all the connections are encrypted using TLS, so you cannot even open an unencrypted connection to Data Lake Storage Gen 1, which is very good. The authentication is built by integrating the service with Azure AD, so you can only authenticate using Azure Active Directory uses of service principles. And then on the access control, it goes down to a file level, so you can specify, of course, to every single folder what are the specific read, write, and execute permissions for a certain Azure AD user or user group, but also you can drill down to a single file and do that even on a file level if you need to do that. Going back to how does these distributed file systems work? In the case of Data Lake Storage Gen 1, it splits the large files into smaller chunks, 2 GBs in this case. So if we have let's take an example that we have a file size of, let's say, 7 or 8 gigabytes, it would create 4 extents for us. So if in sequence, so the first 3 would be full 2 GB size of extents, and then the last one would be the one that would be then, in case of a 7 GB file, it would be a size of 1 GB. And then it has the replication factor of 3. So if you compare this to blob storage, it would be the locally redundant storage option there. So three different copies on across the data center there. And of course, what that means then, or what's the sort of what does this mean from the processing perspective? If we process a large file which is sitting on Data Lake Storage Gen 1 using Data Lake Analytics, for instance, we can, for instance, on this case on the right hand side, we have a total of 5 extents and total of 5 vertices. And what that means is that, let's say if we have a file which is size of 10 gigabytes, and it will be split into 5 extents, that means that on the Data Lake Analytics side, where I define that how many workers am I going to be using to process this particular file, it will parallelize so that I can use up to 5 workers to process that in parallel. If I define which I can do to have, let's say, 7 workers to process that 10 GB file, I already know beforehand that 2 of those workers are just going to be idling all the time because the number of extents defines that how well will the processing parallelize for me. And of course, the same applies for writing as well. So the idea here in when using these big data technologies is that you will be using several nodes to process the data, and then of course to read and to write, and of course that means that they're all processing a small subset of the data, and it's the total aggregated throughput which will at the end of the day give you the necessary power that you need for your processing purposes. If we take a look at how the distributed file system or data lake storage Gen 1 works in more specific, here we have a sample file called XYZ. And the first service that we have there under the hood is called naming service, which stores the folder structure and hierarchy, and as well as the access control lists. So if we take the file ID 123 from this one and query that file ID from the partial file management service, we notice that we have two different partial file IDs for that. And the first one is stored on Azure storage, and the second one is stored on Cosmos storage. And if we take this partial file ID 1 and query that from the extent management service, we find out that there are a total of 3 different extents, and each extent is actually a single blob in a specific storage account. So the data lake storage Gen 1 splits stores the extents on different blob storage accounts to overcome some of the limitations that blob storage has when it comes to throughput. And also we have something called Cosmos storage here that just like the Azure storage has a separate extent management service, so we can actually have the file partially on both of these different storage services. And the Cosmos storage does not have anything to do with Cosmos DB, it's separate file system there. So if we look at this from architecture perspective, we have the highly available microservices, so namely the naming service, extent management service, and partial file management service that we discussed on previous slide are here. Then we have the backend clusters where the data is actually stored, and then the front-end clusters as well. So if I talk briefly this one through, we have the REST API, obviously. Then we have the authentication integrated with Azure AD. Then we have something called small append service, which detects in real time if you're only doing small appends to your file, and will store those small appends into a temporary durable buffer, and then write that into the storage as a larger chunk, so that you will have also the tail of the file faster available for read operations. And then we have the CPU store service, which communicates with the highly available microservices tier here, and actually the one that we didn't discuss yet is the secret management service here, which handles the keys when encrypting and decrypting the data. So we have the secure store service that encrypts and decrypts the data on the backend, and then we have something called transient data store, which is used to store some intermittent results for the data lake analytics runs. So notice that the ADLA containers, also known as yarn containers, are running on the same nodes where the data actually is stored. So unlike pretty much all of the Azure services today, the Azure Data Lake Storage Gen 1 and Data Lake Analytics are actually not separating the compute and storage, which obviously brings it some more throughput and performance when it doesn't need to go over the network as much. And then, of course, from this perspective, the Azure storage or blob storage is an external storage. So when I mentioned that this is built a lot better when you compare this to HDFS or Hadoop's distributed file system, it's especially the highly available microservices here. This is just a single process if you compare this one to HDFS, and having those separate microservices enables Microsoft to scale them independently as well as to optimize them for their specific access patterns as well. So that's sort of what also brings some additional scalability when comparing to Hadoop. So if I wanted to point out one single thing about why is it important to understand how the data is stored on a distributed file system, it's due to the fact that regardless if I use Data Lake Analytics to process the data on Data Lake storage, or if I use, let's say, if I have on-premise Hadoop and I'm processing data there, or reading it from the local HDFS, the same idea applies there, that HDFS stores the files in small chunks called blocks, and then when you process it with your Hadoop cluster, actually the mappers are reading the blocks there as well. So from that perspective, something you probably want to be aware is that what is your block size on HDFS or the extent size on your data lake storage, because that's also defines that what sort of your minimum optimal file size in a way, because distributed file systems are very bad with small files due to the fact that they have some overhead because they are splitting the files on several disks. It means that you probably want to optimize the file size so that your sort of small files or smallest files are at least the size of the extent as such. So by default, HDFS, for instance, has a block size of 128 megabytes. So you shouldn't optimally have files that are smaller than that from a processing perspective. If we compare the data lake storage Gen 1 and blob storage, we are able to see quite easily that from data processing perspective and analytics perspective, the Gen 1 has sort of an edge there. The only sort of capability that it's currently lacking is the geo redundancy there. And also, like from authentication and authorization perspective, we have finally gotten rid of generating and regenerating those shared access signature tokens, which helps a lot with the maintenance work. And one of the reasons why I wanted to start off this presentation by comparing or showing you the data lake storage in Gen 1, and blob storage was the fact that Microsoft now has introduced the data lake Gen 2, and the way that they position this service is that their sort of marketing message there is that it's combining best of both of these services. Now, if you think that from a technology perspective, there are like 3 different options for building a service that includes all the best functionalities of both. First one being you just create the whole thing from scratch. Second option would be that you create or implement the missing functionalities to blob storage, and the third option would be that you implement the missing functionalities to data lake storage Gen 1. And what Microsoft has done here is that they have taken blob storage and implemented the missing capabilities there. What that means is that on the blob storage we had the blob API, and then on Gen 1 we had the hierarchical file system API. Now, and by the way, this is still a roadmap item right now. So they're on their roadmap. What they are going to be introducing is that you can access the same data lake storage Gen 2 using either one of these APIs or both of these APIs. And that being said, if you enable the hierarchical namespace on your storage account today, it will not have the blob API available. So just something to be aware of. And of course, I just since we're focusing on building data platforms and analytics, from my perspective, the obvious question is that do I even need the blob API for any of my use cases? When should I use that one, and when should I use the file system access instead? And for analytical workloads, I would always use the hierarchical file system access anyways. So for my use cases, it's not that relevant. But of course, I could come up with some use cases, like if I wanted to store just large video files or music or something that I know that I'm not going to be doing any analytics on at any point in time. And also if I have implemented a solution that uses the blob API, then that's another use case where I could definitely leverage that API as well. Now, if we compare all of these 3, I guess the statement that this is now, according to Microsoft marketing message, giving us the best of both worlds. Is it doing that? More or less, I would say yes. We seem to have most of the important functionalities in place. That being said, due to the fact that it's actually implemented on top of blob storage, we do have some of the limitations due to that still, like the file size limit here. We have the same file size limit as blob storage has today. On the other hand, like 4.77 terabytes should be quite enough for a single file. Then you just want to split your data into multiple files and work around that issue. So probably not a serious limitation for most of the organizations. and also it has the same price as the blob storage. So of course now the difference there, if we compare the Data Lake Gen 1, we have the Cosmos storage there, and that is something that doesn't exist with the Data Lake Gen 2, and of course that means that the Data Lake Analytics doesn't even work today with the Gen 2. So that sort of brings the costs down to Microsoft, and also enables us to have a really good price point for the service. So some of the best practices that I found when implementing data lakes for our customers is first of all, I would split the data into more than one storage account. So I would have at least a separate storage account for raw data, and then a separate storage account for the created data or cleansed data or data warehouse or whatever you want to call it. So at least 2 different storage accounts there. And then in addition, if I have very large use cases that are using a lot of data, and if they have different data owners, I may consider splitting that further also into different into having separate storage accounts per use case. And that is due to the fact that the Data Lake Storage Gen 2 offers the geo-redundancy today. However, you will need to trigger that failover to the other data center manually yourself, and you will need, and that is an operation that works on the storage account level. So you will not be able to fail over just particular folders in your storage account. You will need to fail over the whole storage account if in case of if a certain Azure data center goes down entirely. So splitting the data into several storage accounts makes it possible for you to decide storage account or use case by use case whether you want to fail over the data and the storage account or not. Because if you have a lot of data owners, really large data lake, for sure in a large organization you will never reach the sort of a conclusion on whether to fail or not. There will be always somebody who's not willing to risk their data and fail over to the secondary location because of they might lose some data. So the Gen 2 also to evaluate whether you want to fail over or not, it gives you a timestamp on when was the last sort of files synced properly, and you can use that information when deciding whether you want to fail over or not. So this is also like per environment. So if you have, let's say if you have your development environment, your test environment, and your production environment, and you want to have separate raw data and created data storage accounts, then that's already 3 times 2 means so 6 storage accounts at least. And then also the services have storage accounts have service level limitations, for instance on the bandwidth usage. So if you're processing a lot of data, you may actually hit that limit as well. So another reason why you could consider, or you should consider splitting the data into multiple storage accounts. So that's the storage layer in short. Next, I'll be discussing the relevant services for actually processing the data, and I'm going to be starting off with the oldest of the services, HDInsight, and what that is. So HDInsight is our Hadoop as a service. It's the Hortonworks' distribution of Hadoop. So what these distributions are, they are, if I take a like analogy from the Linux world, we have different distributions like Red Hat or SUSE or and so on. Also in the Hadoop world, we have different distributions available. For instance, Cloudera, Hortonworks, MapReduce, and so on. So what they have done there, they have decided which of the open source projects to include into their distribution, tested and verified that the specific versions that they have picked from those open source projects work together, and then offering that distribution, and of course their support and consultancy services as well to make some money at the end of the day. So that's the idea. And the HDInsight, as mentioned, is the Hortonworks' version of Hadoop, which means that if you wanted to migrate back to on-premise for whatever reason, you could actually take the Hortonworks distribution, install that to your data center, copy your all of your code and configurations from Azure, and have the whole thing running on-premise as well. That being said, probably something that wouldn't be doing myself, but still very important point from the perspective that we don't have a vendor lock-in for a Microsoft product here. Currently, the HDInsight ramps up in about 20 minutes, so that's super fast if you compare how long would it take to install the Hadoop distribution from scratch to VMs and configure and optimize that cluster for you. So saves a lot of time. If we take a step back and ask the question at this point, that why do we have these big data processing services today? And one of the questions I get quite often when I go to speak about these in various events is that, like, we already have our relational database, and where should I implement our data warehouse, for instance. I'm making this comparison to MapReduce now because it was among the first big data processing engines, open source engines that became very popular at that stage. So if you compare these features there, you probably get the idea that the idea of these is not to compete with relational databases. Instead, the idea is to complement one another. So I wouldn't use a big data processing tool instead of my relational database if I just can process all the data for all my use cases in a relational database. It doesn't make that much sense. If I don't gain anything from the scalability, if I don't need the scalability, then it's just gonna make things more difficult, and I don't have the maturity of the relational databases available today. And also when it comes to, let's say, resourcing, it's a lot harder to find somebody that's good with let's say Hadoop and Spark, for instance, than people that are very good with relational databases. So there are a lot of reasons why you shouldn't be you probably don't want to pick them for your use case unless you really need them. So if we look at how Microsoft sees the Hadoop today, they foresee the future as our enterprise scale data warehousing framework. And if you look at the different things that they have introduced along the way, for instance, the ODBC, JDBC drivers, something that enable us to connect pretty much any given business intelligence to our data warehouse today. Then if we take a look at for instance, TES, vectorization, ORC, all of these deal with performance optimization at the end of the day, as well as the in-memory LLAP as well. And of course, ACID capability is very crucial if you're building a data warehouse. Without going into very much detail on how MapReduce work in MapReduce, with this picture, I just want to show you that there are some reasons why the MapReduce execution engine as such isn't being actually used anymore, hasn't been used for some years now, because the way that worked is that the map actions, and first of all we have the map actions, then we have the reduce actions, and after that we always need to write back on a disk, and then after that we can do another MapReduce, and then we need to, at the end of the day, we need to save all the intermittent query results on the disk all the time, which gives us a very big performance hit. And that's one of the reasons why we have a execution engine called TES today, and the difference here is that it can actually do several reduce actions or one after another, so we don't need to write into disk. It tries to keep all the data in memory all the time, as well as the introduction of LLAP, which stores the data sets in memory as long as it can. So also like after the execution or after your query has ended, so you will notice a very big performance difference if you run a query once against a set of tables and then run the same thing again, because you will have hopefully most of the data, or optimally of course all of the data, still available in memory. So that's something that they have implemented there within the past couple of years to optimize the performance even further. So these are all available in the latest HDInsight versions, and they are also configured now by default. So if you provision HDInsight interactive query cluster, you will have the LLAP there with TES by default, and as mentioned, TES has been the execution engine for years already. So the HDInsight also included Spark as a technology, but I deliberately left it out because I have another service called Databricks, which I'm going to be talking or giving you an overview about. And what this is basically Spark as a service. So if you're not familiar with Spark, let's go and check how Wikipedia defines Spark. So this one is a distributed computing framework. So pretty much same idea as with Hadoop, but here they have just focused solely on developing a very good execution engine, whereas Hadoop is a framework and includes various technologies all the way from the storage layer, which is the HDFS there. And one of the reasons why I wanted to show you this is the fact that we have Mate Zaharia here as the original author for the technology. And if we take a look at who's this guy, he basically invented Spark during his PhD studies, and now, as it mentions here, he's one of the co-founders of Databricks as well. So, long story short, Databricks knows the Spark technology pretty much inside out, and according to Databricks' presentation, they have written like 75% of Apache Spark's source code as well. So they're the guys who are behind Databricks, and given the fact that it's Spark as a service, of course, the natural question is that, so what are they adding on top of just open source Apache Spark? Of course, we have all the connectors to relevant data services on Azure. We have the billing there through Azure as well. We have integration with Azure Active Directory, but also one of the things that I would like to highlight there is the fact that they have really put a lot of effort into creating a platform for you to collaborate on. So it's a lot easier to develop the code for Spark with your team using Databricks than having your Apache Spark installation up and running. So they separate the actual code and clusters, unlike HDInsight, which means that you can pick and choose that which cluster do you want to run your execution on after attaching that specific notebook to a specific cluster. If we take a look at how this one looks and how it stands out from if we compare this to, for instance, to Hadoop, we have the machine learning capabilities there, as well as the structured streaming capabilities based on top of something called data frames and data sets, which under the hood are always operating on top of RDDs, or resilient distributed data sets, which is the lowest level of abstraction of data on Spark. And the catalyst there is the optimizer for your processing. So if we look at this from architecture perspective, the driver program Spark context is the sort of the master there, and then we have the executors running on worker nodes here that are actually doing all the heavy lifting for you. So it's the master that asks resources from cluster manager. There are different options for cluster manager. For instance, Spark's standalone one, and then Mesos and Yarn, for instance, to allocate or to give the master the resources to actually execute your code in parallel on several nodes concurrently. So then it's the workers that actually connect to the data sources, do the processing, and then store the result sets back into a specific storage service that you are looking forward to. use. And one thing that I would love to highlight when it comes to processing data with Spark is the fact that RDDs is the oldest, and of course, as mentioned, the lowest level of abstraction for the data. So that's your data basically in a schemaless format. And then the data frames and data sets are when you define the schema for your data. And of course, then as mentioned, it uses the Catalyst optimizer to optimize your processing. So logical plans and optimizer are available when you're using this. And so the difference here is that you can operate directly on RDDs, but in that case you are specifying what you want to, or how you want to execute, how you want the execution to be done. But if you're operating on data frames or data sets, you're defining what you want to be executing, and then it's this guy, Catalyst Query Optimizer, that will do a lot of work for you under the hood to make sure that your query is optimized. So wanted to show you this to make sure that you are aware of that and are hopefully using the data frames or data sets by default always when processing the data. It will be super difficult to optimize your code on top of RDDs to run even close as fast as if you're operating on data frames and data sets. So enough of the talk. Let's see how these services actually work. So what I have here is I have created on Azure portal, I have created an HDInsight cluster as well as Databricks cluster. If I quickly show you how Databricks looks like, the most important features are the clusters here. So you define what kind of a cluster you want to provision. I need to ramp up my cluster for the demo. Looks like it was automatically terminated because I had defined here that terminate after 60 minutes of inactivity. So you can define that, and it will save a lot of costs for you. And also, I have also enabled auto-scaling, so that in this case, if it sees a heavy workload, it will increase the number of workers to 2. So if you wanted to create a cluster from scratch, you would go to clusters, then create a cluster, then you would give it a name, define which version you want to be running on, as well as when it comes to the Databricks, as well as which Python version you are looking to use. Then the workers means that which kind of VMs you want to use to actually do for your processing, and then the driver is, as mentioned, the master node there, just handling the not doing the execution, but managing it. You can also set some advanced options here. One thing I want to show from here is that if you want to have your users or have a more sort of a secure setup for your business analysts, you probably want to use the high concurrency mode here, because it brings us new functionalities under the advanced options here. So if I set this one to high concurrency, then I have these options that I can define table access control as well as credential pass through to data lake. So what that will do is that it will actually pass the Azure AD credentials of your end users directly to the data lake, and use the and do the authorization via that. So then you just need to define, of course, the access rights on the data lake storage directly, and then you need to give your end users proper permissions on Databricks so that they can process their or query the data in the that they have access to. And then another concept, let's see, my cluster is still ramping up, is of course the notebooks. So here's my notebook that I created for this demo. So you can just, there are 4 different languages that you can use for writing your code. So you can use Scala, you can use Spark SQL, which I'm using here. I'm defining the %SQL here to define that the code in this particular cell is going to be Spark SQL. Written this demo in SQL. I would assume that most of the attendees in a PAS webinar are familiar with the SQL. So if you're familiar with SQL, it's actually going to be pretty straightforward getting your first queries up and running. And here you can define which cluster you want to attach this specific notebook. So which one do you want to use for execution? Then what else I have here? I have the HDInsight cluster, of course, and you can just basically write your first. So this is a fresh installation of HDInsight, and if you are like the typical first query that all the users do is that they notice that there is a default database and a Hive sample table, which gets provisioned also when the cluster is created. There they will write select star from Hive sample table to get a bit of an idea of how does this work. So the Hive query language is also another SQL dialect. So it's if you're familiar with SQL, it's super easy to get started also with these big data technologies. Looks like I have my cluster up and running now, so I can actually see the data that I have here. So all the sort of meta database or tables that I have created that point to the actual data in the data lake storage. So I will show you quickly how to create a table. It's basically, here's what you want to do. Just create database, then create an external table which will then point to a specific location on your Azure Data Lake. So it's this easy to create tables, and one of the things that I wanted to show you here is that yes, the Databricks also shows you the default and Hive sample table here in this case, and if I create the database demo and some external tables here by running this query like so, that was executed. Then with the given configuration that I have, they should also pop up here on Databricks, and they should be here also available for queries. So if I now start executing these queries, they will actually work for and I'm also able to work with the same data sets, both from Databricks and as well as from HDInsight. So I'm a bit running out of time, but the reason why I wanted to show you that one is because this is actually one of the important patterns that I always use in customer cases. So what I have there defined is an external Hive metastore. So I've created an Azure SQL database, and I have configured both of these clusters to use the same metastore, so that whenever I create a database or table in one place, I can use the same metadata to query the same data in the other service. And of course, the reality looks more like this. So you're probably going to have a lot of clusters, both HDInsight and Databricks, and you can configure all of them to use the same metastore, so that whenever you create a new table, it will be available for all the different use cases as well. So as a short, how to get started with big data processing, my suggestions would be that learn one of the distributed file systems. HDFS is a good candidate because it's an open source project, so you'll have a lot of information available for free on the internet. Unlike with most of the cloud services, you cannot drill down into those as deep as you can with HDFS. Then learn one of the cluster managers or resource negotiators. Yarn is a good candidate for that, because just like HDFS, it's a open source project. And then of course one of the execution engines. I put Spark in here as a candidate for that. And of course the easiest way is to upload some data in the data lake, create the service, create a table on top of that, and just start using them, and then you can go back to the literature and check and understand a bit better how these work. So I think I'm out of time, and also presented what I want to present today. Jason, do we have any questions online?
Yeah, thank you. We've got just one question here so far. The question is choosing SQL Data Warehouse and Analytics category in Azure pricing calculator, there's only the possibility of choosing 1 terabyte or more for storage with about 114 euro per month. Is it possible in real Azure environment to choose less than 1 terabyte in respect to those costs for testing purposes?
So you will be still billed based on the actual data that you're using there. If the calculator shows 1 terabyte as a minimum, but you only have, let's say, 500 gigabytes of data, then of course you're only going to be paying for 500 gigabytes. So you mentioned the storage, and then the data lake.
SQL Data Warehouse.
SQL Data Warehouse. Slightly perhaps off the topic of this particular, but let's take a look at SQL Data Warehouse here. Yeah, looks like the starting is at with the pricing calculator, it starts from 1 terabyte. I would almost argue that if you have less than 1 terabyte of data, you shouldn't be using SQL Data Warehouse.
Yeah, I think the other catch that you're going to get in there is that it's a dual cost. There's the there's the storage cost and the compute cost, and the compute cost is always much higher, or often much higher.
Yeah, that's true. That's true. Yeah.
Now, I don't remember, there used to be adjusted pricing for MSDN licenses for testing, but I don't recall if they still support that. But yeah, it looks like that's just going to be the price for it. So let's see. Are there any other questions, folks? All right. Looks like there aren't any more questions. So thank you very much for presenting today. This has been a great session. This is always great information to get into. Thank you for presenting. Thank you, everyone, for attending. We do have, as I mentioned earlier, we have another presentation on Thursday and pretty much 2 every week going forward. So thank you again, and goodbye, everyone.